Classic probability. The odds have something happening. We have two concepts, union and intersection. Union uses this symbol and intersection uses that symbol. You have that formula for union and the other formula. We have general formula for event A and B, and S is going to be like your general population. Then we have a classic probability that the example is the probability that the US wins the Olympic game is 0.4, and the probability they win the World Cup is 0.15, and the probability that they win both is 0.05. We have data, and the process is P intersection with B is going to be 0.5, and to get the other two numbers is A minus the intersection between A and B, and the same for event B. You gotta get 0.35 and 0.1, and the union is gonna be A union with B.
Now we're going to see conditional probability. Conditional is a probability of event A occurring given that event B has already occurred. In this case, event B is a condition. You can also read it as the probability of A given B. For example, if we take that Susan took two tests, the probability of her passing both tests is 0.6. The probability of her passing the first test is 0.8. What is the probability of her passing the second test given that she has passed the first test? Okay, so you have to divide the probability of her passing the first and second test between the probability of her having passing the second test. You do this and it gives you 0.75, and that's the answer.
The third topic of this project is counting, and counting, depending on the case, it can be used with different methods. It can be used with factorials, combination, permutation, or the multiplication method. The first method is factorials, and factorials means that it's an integer positive represented by the letter n, and then denoted by factorial n. That is the product of all the integers between 1 and n.
The second method is permutation, and is another arrangement of a group of objects where R means object selected and N means objects given.
And then the combination method is really similar to the permutation method, but in the combination does not matter the order.
And the last one is the multiplication method, where the idea that it's like the idea that if there are ways of doing something and B ways of doing another thing, then there are A times B ways of doing both actions.
Now we have the counting problems, and for each method there is only one problem. The first problem is about the factorial method, and it says about 7 is the representation of n, and we need to find the factorial of 7 with the factorial formula. Then the second one is about combination. Our objects given are 20 and the objects selected are only 3, and this problem does not say anything about the order, so it's combination.
The third problem talks about permutation, and this one is basically the same of combination, but the difference is that the order does matter because there are 20 teams and they are asking us to choose, to find the first, the second, and the third place. And the last one is the easiest because it's a multiplication method. We're given 7 coffee methods, 5 types of paninis, and 5 different desserts. So we just need to multiply each one of them, being like A times B times C.
Now we're going to see dependent and independent variables. An independent variable is a variable that represents a quantity that is being manipulated, while a dependent variable represents a quantity whose depends on those values manipulated. There are 3 letters. In the letter A is the Xbox, the students that have it, and the result is 40% if we divide it. Then in the letter B are the guys that have PS4, and it's 26%. If we multiply that values, it gives us 0.104. That value is what we are going to use. In the letter C, there are the guys that have both of them, so the result is 20%. If we compare it, the result is that both are dependent.